Hey guys, so today we'll be solving sort array by parity. Uh, to begin with, the problem states that let's say there is an array. So the problem requires us to arrange all the even numbers at the beginning and the odd numbers at the end. So we can arrange the even numbers like this, or like this. So basically the order doesn't matter, it's just that we have to arrange all the even numbers at the beginning and the odd numbers at the end. So one idea for this problem is like there are several edge cases we have to consider. For instance, let's say delete this, and let's say we have some an input like this. Let's say 5, seven, let's make this 6. Let's make this an even number, 7, 1. So basically the idea is like we use 2-pointer system, one for the end and one for the beginning, and we check this number at the end. If it's an odd number, we decrease the counter, and for this, if it's an even number, we increase the counter. So it will go from index 0 to index 2. So again this will come to the next index, and because this is an odd number, we can ignore this. We can ignore this and the pointer will come here. So at this place we find that there is an even number. So our idea is like we interchange this with the first pointer. Let's say this is an I, this is a j. So the element at the j position will be interchanged with the element at the I position, and so this becomes 4, 2, 6, 5, 3, 7, 1. And if the element at this leftmost position is an even number, we increase the counter, and similarly for this. And so there is one other catch. Let's say we have an arrangement like this. Let's say this is 8, 1, 3. So it will traverse fine till here. Now for this position we see that the element at this position is an even number, and also the element at this position is an even number, but the priority is like we get all the even numbers from this rightmost part, come here in the leftmost part. So when we interchange this, we will get something like this. We get 8, 5, 7 6 3. Now notice that after interchanging, the element at this position is still an even number. That means we cannot traverse in this direction. That will be wrong because we still have a even number at this position. So whenever we get an even number, we halt or stop this rightmost index at this position and wait for an odd number to be replaced by this. So because this is an even, we can traverse here to the right. And then we see that this is an odd number, and when we interchange this, we find that this is an odd number, and similarly that this is an even number. So because this is an odd number, we can then safely traverse towards the left and make this right pointer go towards the left. So that's the main idea. That's the edge cases or the corner cases for this problem. So coming back to the code, so we'll take two indices, one index for the leftmost part and the other for the rightmost part. Now we traverse while I is less than j. So in each traversal, we'll check whether element at position r is an even number or not. If it is, then basically we interchange the left and the elements at the left and the right indices. So element at a and r, l and r will become elements at ar and al. So basically this is a shorthand this is like a shorthand way by which we interchange position in JavaScript. So that's pretty cool. And then after interchanging, we need to check whether element at the rightmost index is divisible by 2 or not. If it's not divisible by 2, then we can safely traverse here. I think I did some mistake with positioning of the brackets. Yeah, so this will come here. Yeah, I think that's fine. And we similarly have to check for the leftmost index. For the leftmost part, we have to check whether it's an even number, and if it's an even number, then it's safe to make the pointer travel towards the right. So yeah, that's it. At the end, we're returning. Let's run the code. Okay, we have an error. While I is less than j. Oh, it will be okay. This will be, let's say, L and R. Make this L and R, and I think that's fine. Yep. And that's it, guys. So the complexity is like O of n, because we are just traversing the array, and space complexity is O of 1 because we are not taking any extra array or any other extra space. So that's it, guys. I hope you enjoyed solving this problem, and If there are any doubts or questions, you can post it down in the comment section below. And as always, do like and subscribe this video and channel if you like to see more of this type of content. And I will see you in the next video. Thank you.